In this video, I'll show you how to use JUMP to create a confidence interval for comparing two means from independent samples. I'll be using the data from the Ginkgo supplement experiment. Whenever you're comparing two means using JUMP, the data needs to be entered in a very specific way. You need one variable which represents the grouping variable, and so for each individual in this study you need to record whether or not they ended up being assigned to the placebo group or to the Ginkgo group. And then the second column is going to be their value on the response variable, in this case their score on the memory test. So notice that each row represents a different individual in the study, and for each individual we record their group or their treatment and their response variable value. If you have the data entered in this way, we're going to go to, it's under Analyze, Fit Y by X. So the response variable in this case, when we're comparing two means, is always going to be the quantitative variable. So for us, that was the memory score was our response. And what we're thinking helps to explain changes that we observe in the response is the grouping variable treatment group. So that's our X variable. So in order to do this analysis correctly, you need to make sure you have a quantitative response and a qualitative explanatory variable. Then click OK. Now, I actually really like the graph that it produces by default. It gives you a nice immediate visual of whether or not there seems to be separation between the two groups. So you can see from this graph, it looks like the Ginkgo scores are a little bit higher than the placebo scores on average, but there isn't a super big distinction. It's just kind of subtle. And so we can ask JUMP to create a confidence interval for us to see if there is a statistically significant difference between the two groups. So to do that, you click on the red triangle next to one-way analysis, and we're going to be going down to t-test. So it gives us a lot of output by default. One thing you're going to want to pay particular attention to is the order of subtraction that JUMP uses. We actually don't have any control over this order of subtraction. There's nothing about the way that you enter the data that's going to do the subtraction in the order that you want. So you have to be able to take what JUMP is giving you and then potentially reframe it for your purposes. So in this case, we're looking for the confidence interval, and so you can see the confidence interval input is down here, so it gives us the upper bound for the confidence interval for the difference, and the lower confidence limit for the confidence interval for the difference. And you'll notice here we're given the confidence level, and so it does 95% by default. And so to change the confidence level, here we wanted a 99% confidence interval. We go back to the red triangle next to one-way analysis, and we come down to set alpha level. So you can see it gives us the 0.1, 0.05, and 0.01 that are pretty standard, but it also does give you the option to choose another alpha level if you like. So since we want a 99% confidence interval, our alpha level here is 0.01. So we can see that when we're estimating the difference placebo minus Ginkgo, the lower limit is negative 0.5127 and the upper limit is 0.25522. JUMP also gives you the degrees of freedom, which, as I mentioned, are given by a messy formula that is going to result in having these decimal values in your degrees of freedom. So here the degrees of freedom are 64.75008. Some other output you might want to take note of here is that JUMP calculates for you the difference in sample means. So here it's about that negative 0.13, a little bit more precise because we rounded when we were doing the calculations by hand. And also gives you the standard error for this difference. So here that's about 0.14 like we got when we did it by hand, just a little more precise because it's using all the data values rather than doing rounding and having precision errors along the way. So this is how you can get JUMP to calculate a confidence interval for the difference in two means based on independent samples.